Good morning and welcome to lesson 3 of structure of an atom, particles, etc. And to start with, just thinking back to what we've done before, remember this is now going on to the modern structure of an atom. What we had before was Dalton's model, that it's just a sphere. Then we had Thomson's model, that it was a sphere of positive charge all spread out with little negatives, so the plum pudding model. Then we had Rutherford in the last lesson showing that actually of an atom it's only a very small bit in the centre that has all the mass. The rest of it was empty space. Then building on that, still the nucleus with all the mass in it, all that empty space, and then electrons going around the outside in orbits, and that was Bohr. And then Chadwick worked out that actually, as well as positive particles in the centre, there was also neutral particles, and he called them neutrons, and still the electrons going around the outside. So we need to go into a bit more detail on this modern structure of an atom. So to start with, could you please write the questions and then the answers, and we'll go on to that in a second. Obviously pause, I won't wait. Okay, I'm thinking you've done that, so we'll move on. Who did the gold leaf experiment? Ernest Rutherford. And there's your other questions. There's your particles here, over here in a liquid, just there. Abiotic is living, abiotic is non-living, biotic is living. And the movement of particles: solids vibrate, liquids flow or slide past each other, free to move, and gases move freely. Okay, hopefully you got most of those right, and if not, you've got the answers there now so that you've revised it this time and you'll get them right next time. So, modern structure of an atom. So what we had so far was this idea that from Rutherford and Bohr and Chadwick, we've got a nucleus of an atom, and then we've got lots of empty space, and then around the outside we've got places where, and they're not physical things, but they're just orbits of electrons. Ooh. There you go, I've drawn 3 electrons in this one. So an atom is made up of 3 different types of particles. In the centre here we have a particle that we call a proton, and that has a positive charge. And you can have 1 of those, you can have 2 of those, you can have 100 of those. And you have particles in the centre called neutrons, and they have no charge. On the right, none. And then these little tinier particles, much smaller than protons and neutrons, and not really weighing anything, they're so tiny, that's what causes electricity, and those were called electrons, and they had a negative charge. So these are the 3 smaller particles that made up an atom, and they didn't know about these, and they couldn't have as much evidence when they were building the model, the atom model, but now we have a lot more evidence and a lot more proof that these are the 3 particles that make up every single atom. Now, how does it work from the periodic table? Well, for example, on the periodic table it might have, let's just say, sodium, and next to it it has 2 numbers, 11 and 23, and this tells us on the periodic table a load of information. So first of all, it tells us that there are 11 protons, and that is the atomic number or the proton number. That's the number of protons. So it tells us that the proton number is equal to 11. That's easy. That means we have 11 positive charges. Now the other thing is, all atoms, before they react or before they join with everything else, the number of electrons and protons was found to be exactly equal. So it also tells us that in an atom of sodium, Na, the number of electrons equals 11. 11 negative charges. And that means if you've got 11 positives and 11 negatives, overall an atom has a neutral charge. So every atom always starts with a neutral, to make that more obvious, there's a U, neutral charge, and that's an R. Good writing. Now, this number down at the bottom is called the mass number. And that's how much one atom weighs in atomic mass units. So, this one weighs 23 in total. But what I have to do is I have to take away the 11 protons. Because in total it's 23. There are 11 protons, that's the number up the top there, here. And that means it leaves me 12 left over. And if you remember from Chadwick's work, what are those other particles called that also weigh something? If you remember, electrons don't weigh anything. That means it has 12 neutrons. So, if I was you, I would, number one, pause now and do that diagram showing the particles in an atom, and this diagram here with what does it tell us. When you've done that and you've got that in your notes, unpause. So here we are. Exactly the same thing, a little bit of a better drawing. This one has, it's got those 11 electrons. If I count them up, I've got 1, 2 here. Then in the next orbit out, I've got 1, 2, 3, 4, 5, 6, 7, 8. So I've got 10 so far, 11. So those are the 11 that I've just drawn a minute ago. So that's the nucleus in the centre of the atom. That's the protons and neutrons can be found in the centre. And what they've done there is they've done red for one and yellow for the other. This is the electron travelling around the nucleus. And this is the shell that shows the path of the electron. So it's not a physical thing, but they go, this electron here, for example, is going wee, wee, and orbiting round and round and round and round and round. So, all of the rest of this in the atom, all of this is empty space. And that makes up most of an atom. So if you remember from an earlier lesson, we said that if you had something the size of a football field, the actual nucleus would only take up, I've drawn a dot in the middle if you can't see it, the size of a marble. So actually most of an atom is empty space. So could you now copy this diagram into your notes with all the labels? Try and make it as neat as possible, because we're going to draw a lot of these. Okay. So, looking at protons here, a proton has a positive charge and they weigh 1 unit each, 1 atomic unit. The neutron has no charge, 0 charge, and it weighs 1 atomic unit. And the electron has a negative charge and it has no mass. It's so small, we say that it doesn't even weigh anything. So those exact same things are in this table down here. So, good idea is to have that table really clear, maybe highlighted, because that is always tested, and that's something you'll need to know off by heart, quick recall, and just be able to go, oh yeah, protons weigh 1, they're positive. Neutrons weigh 1, but they're no charge. And electrons don't have a weight, but they have a charge of -1. That's something that you need to just know right at the top of your brain for all of chemistry. Okay, so pause now and copy down that table. And unpause when you're ready. So, just done a couple of diagrams, and what you have to be able to do is draw the electron structure. And down this side here are the rules. You always fill the shells closest to the nucleus before you move into the next one. The first shell can contain up to a maximum of 2 electrons, and then the next shell has a space for 8, the second shell, and the third shell again is 8, and the next shell, the fourth shell, is 18, because they're getting bigger as they get further away. That means the maximum number of electrons you could have 2, then 8 in the next shell, then 8 in the next shell, and then 18. And you never have to go any further than that at GCSE. So, here's carbon. It has a mass of 12. It has a proton number, or atomic number, of 6. And because it's got 6 protons, that means we can work out, it has, and this is the first thing you do when you're drawing them, it has 6 electrons. It's always the smallest of the 2 numbers, either if they're written at the top or the bottom, it doesn't matter. So, it's got 6 electrons. So I'm going to draw a carbon. All I'm going to do for the nucleus is show that it's a carbon atom by putting a C in there. And then I'm going to draw my first shell of electrons. And I can fit a maximum of 2 in there. So I'm going to go 1, 2. I've used up 2 of my 6. I've still got 4 left. So I need to go on to the next shell. I'll only draw this in if I need it. And I'll go 1, usually drawn in pairs, 2, 3, 4. Absolutely amazing. Well, I have got it right. I have got 6 electrons, 2 in the first shell, then I've gone into the second shell here. I haven't filled it up with 8 because I haven't got 8, because I only started with 6. 2 in the first shell, 4 in the second. That is the electron structure for carbon. And as soon as you've done a few of these, I think you're going to find it really easy. What's really important, try and draw, unlike mine, maybe use a compass or something to draw around, but try and draw slowly and try and draw neat circles. So don't rush it, and it's probably easier for you with a pencil in your book than it is for me on the computer screen. Okay, so from this periodic table, if I asked you to draw any of the ones near the top, so for example, if you got asked by me or in an exam situation or something to draw oxygen electron structure, over here I find oxygen, it's got an O, an oxygen, and I go, it's got 16, that's the protons and neutrons added together, the mass, and it's got 8 protons, so it must have 8 electrons, and then I go to myself, 8 electrons. Oxygen, put an O in the middle, maximum of 2 in the first shell, 1, 2, I had 8, so I've used 1, 2, 3, 4, 5, 6, 7, 8. There we go. Bing, it's correct. I have 8 in there. So, I would like you to draw the 4 of these for yourself, and that's the work you need to submit. So you'll start by going to the electron number, the proton number. You'll put an Li in the center. You will then put your first shell, put a number of electrons in, so I'll do lithium with you. I've got 3 in total, so I can fill up the first shell with 2, then I need to add the next shell on, and I need to put in 1. There's my 3 electrons. So, can you do the same for beryllium, sodium, and magnesium? And do those 4, and that's what I want you to send me a photo of and submit through Google Classroom. Okay. Then, the second part, could you pause now and just check that you can answer these questions? I would write the question and then the answer, and then once you finish that, go on to the answers and mark it, send me a photo of that. Pause now please. And when you're finished, go on to the answers. Mark yours please and send that in. Excellent. Okay, try and make the live lessons if you can, and if you can't, keep doing the recorded ones. Brilliant, thank you.